Hello everyone and welcome to the CSE116 Task 2 Game Features 2 overview. In this task, we're going to be going over LinearGame, Mario, and even Pathfinding. Exciting topics. We're going to start with the LinearGame, we're going to go through the handout, see what's up there, we're going to dive into Mario, and then afterwards we're going to talk about Pathfinding, Find Path, and why it's important to do some of these things now to make future tasks easier. Little heads up, most of these clips you're going to be seeing in this video were recorded from last semester. The content is mostly the same. If you see a few differences in the handout in terms of like some crazy stuff like LOs and CUs, don't worry about it. Just worry about the content of the task. That stuff remains the exact same. So same material there, don't worry about it, but there is some new stuff here and there that I'll be pitching back in to talk about. So with that being said, let's get right into it. Alright, so first up, we're going to look at what Mario will actually look like when it's completed in the game and what this whole linear game, linear level stuff is about. We're going to look at that, so let's get into it. So right now I'm in the configuration file, which you could always remember find by pressing Shift and then typing configuration. I'm going to change the game name here to Mario, and then I'm just going to run the start game, and we're going to see Mario. I turned off the audio because it was super loud. Oh, well, I still got that one. Okay, so I'll try to talk over this, but so, yep, this is what it's going to look like. It's Mario, and you could play the game for the most part. And you could just jump around and you see the gravity working and everything. It's pretty cool to just, play it and know that like you help make the mechanics for this. So it's really cool. But yeah, also a big thing here is not only the gravity that works, it's also the level management. So once you complete your level stuff, you'll be able to go to the next level, and you'll be able to see all that working. It's super loud, I'm sorry. I'm just gonna get to the end here to show you one more time. You just hit the pole, you're gonna go to the next level, and yeah, it works great. And as long as you have all of your methods implemented correctly with advanced level, storing all your level data and all that, then it should work, and you'll be able to play Mario, and it's super cool. All right, that's exciting and all, but that's not all. We also have the pathfinding portion of the task, which exciting on its own. So let's take a look at how we're going to be able to visualize that to know that we've got something working. Yeah, so that's Mario, and I'm also going to show you the to do that. I'm going to change this thing in here really quick. I'm not showing anything critical because this is actually all given to you. If I'm going to go over this in a little bit, but this agent class, we give you a bit of code that you could just copy right in or write yourself, which this is described to write yourself. Again, I'll go over this in a little bit, but this is to help visualize what your CU code is doing for this task, because you're not going to be able to like play anything directly yet, because that's going to be done in task 3. But now if I go to sample game and I play this, we're going to see, hopefully, yeah, okay, we're going to see some pathfinding stuff. So we see the paths generated by these two demon entities. One was up there, it started like in the top right, and it pathfinded right towards me. It's fine that they're going through the walls. That's like how it's meant to be right now. But as you can see, this guy started down there, and as he went closer, his path changed and got shorter. I'll show that one more time. But it's really cool to see the visual here, and that your pathfinding is actually like working. Because later on, we're going to make it way smarter with them going around walls and stuff like that. But for now, it's going to help you so much for task 4. And it's also pretty cool to watch this happen. And again, like I mentioned a bit earlier, there's some tactics that you might be able to use to make this be a lot easier than it might be with a iterative, while loop method. But we'll get into that in a bit. So let's take a look more at the doc. So yeah, like always, we see that there's only a few files we need to modify, which are these 4: LinearGame, PhysicsWGravity, level parser, test utils. So again, if you're overwhelmed with the bulk of the project here, there's so much stuff in here, you could just shift it and find whatever you want.
So if I wanted to find LinearGame, you know, I know, like, I've mentioned this before, but I always mention it because, like, I know it's an overwhelming, like, there's a lot of files here. It's, I understand if it's, like, hard to go through all these, and, like, a lot of them you don't need to ever look at. Like, this display thing, you never need to go in here, really. Like, there's many files that you'll never have to look at, but this is kind of the point of 116. Like, if you want to look at it, you can, and you'll probably be able to understand a lot more as you learn more in the class. So it's really cool stuff. We built, like, this engine was built around, like, the concepts that we learn in class and everything. So it's really awesome. So yeah, a lot of the first portion of this task is very similar to your problem set. Um, I would really take a look and compare the two before you start just blindly writing code, because there's a good chance you might be able to salvage some stuff from the problem set, and think about how you might use that to implement it for this this part of the game features task. The linked list stuff, again, like, I'm not gonna go over too many things of these methods here, like getters and setters. You guys have done those at this point. The interesting ones are remove level by name, advanced level. These two are like the most interesting linked lists methods here. But again, if we just look at the problem set, you guys did stuff such as delete element. You have an add element here. So just take a look at what you did already and compare it to here. And advanced level, that's going to be probably the most unique one. I think it's pretty descriptive, and yeah, nothing too much to talk about there. One thing I do want to mention though about advanced level and kind of these linked list methods in general are to be very careful about modifying your instance variable for your level list, because this is an issue that runs up all the time. Like, if you're advancing your level, you're still gonna need your entire level list. Okay, like, you shouldn't change your underlying data structure when you're calling advanced level. So keep that in mind. Like, if we added like 10 levels to our level list and then we call advanced level, we should still have 10 levels in our level list at the end of that call to advanced level. Just make sure you're considering that and that's on your mind. And yeah. So, where things get pretty interesting though is with the physics engine with gravity part. Here is where we look at inheritance and really see a huge benefit of it. So, we're tasked with looking at the physics engine with gravity class, which extends physics engine. So, physics engine with gravity is a subclass of physics engine. Which, if we take a look here, because it's really useful if we just go in and look at this stuff. Physics engine here, I just shift and got there. So we have a whole bunch of methods in physics engine, but again, we don't really need to do anything in here. So that in a previous task, you guys would have completed this update object method. Excuse me. And there should be stuff in here for you, but that's where we really see a benefit, because if we go to physics engine with gravity, we're tasked with overriding the update object method of physics engine. And in this override, we still call the superclass's update object method, which basically this means that, like, your subclass is still calling code from your superclass and executing that first and then doing its own logic on top of it, or vice versa. So we actually are going to set some gravity to the velocity of the game object, and then we're just going to call our superclass's update object method. So we don't have to rewrite our, like, velocity shifting, like, movement method, because we could just simply extend it and add some extra behavior to it. That's the real power of inheritance. So remember, like, how you override something. You basically just repeat the definition of the method in the subclass, but you should really write the override method to make things super clear. And that's another great thing about, like, kind of working in this big file space, is that, like, you can see a bunch of examples of the stuff that we're learning about. Like right here, we could see that process all collisions. Apparently this is an overridden method, which means that our superclass physics engine probably has a method, well, definitely has a method, process all collisions. Unless it was in some farther superclass, like down the chain a bit, but it's not. This is like the most low level class here. So yeah, process all collisions. So we see a lot of interesting behavior here, and yeah, like I said, we're gonna be overriding the update object method and adding some gravity to it. And it's pretty simple in terms of the amount of code that you have to write. It's not too much, and that's the goal of our inheritance. We don't want to rewrite all of our code again. So yeah, definitely keep that in mind. We have a get gravity and set gravity method, so just getters and setters again. We're gonna want to create an instance variable for gravity and store that ourselves. So we're gonna be storing that somewhere in here, somewhere at the top, and yeah, so we'll be able to see how gravity works now with all that. And technically, Mario and all that, after you complete this physics engine stuff, is going to make Mario work completely. You'll be able to jump up and down and all that. Okay, moving on. Again, this reset method here, it's completely optional. It'll just help you debug like quicker if you'd like. So remember, you don't have to do this reset method, but keep that in mind there. Yeah, and so we're gonna move on from the gravity stuff and go right into the level parsing. Now this is interesting because here's where switch case comes in, and we don't expect you to have seen switch case really at this point. So I'm going to show you what it is, how to use it, and how it is basically exactly like if else's. So let's get into that here. Okay, so I have an example method here just so I could write some code and we could look at it. So what a switch case is basically just a long if else statement that's easier to read. And that's pretty much it. So I'm going to write one out before we take a look exactly at what the level parser is doing, because I think it'll be easier to understand. So just really simply, a switch case, you write switch and you give it some data that we could examine different cases of what it could be. What I mean by that is, like, let's say we gave it an integer, some integer variable, right? Then we could look at different cases of what that integer could be. So I'll do an example here. So let's just say, let's say this method passes us in an integer called x, okay? And we want to switch x. So then we open up the switch case, and then we start adding cases. So let's say, all right, for int x, the case that x is 0. And then we put a colon, and then we write out our code. Like, okay, if x is 0, then maybe, let's say we were returning a Boolean or something. Like, who knows what it is, right? Then, okay, let's return true. Great. Now let's say the case was 1. And so, yeah, you'll notice that with switch cases, like, for some reason in IntelliJ, like, when you press enter here, it'll start you on this line, and no matter what, you can't go back one. So you have to just go type it here, and then it'll automatically adjust once you type the colon. But case 1, let's return false. Okay. And that's like a super basic example of a switch case. Now I want to bring up a few more things about switch case. So I'm going to make this void again, and let's pass in a string this time. So, and let's just call the string name, okay? And now let's switch on name. So if we're switching on name, we could go cases with whatever names we want to put in here. So I don't know, I'll put in Jesse. So in the case of Jesse, who knows, we could do something. I'm going to also mention one part about the switch case syntax, which you're not going to have to use for this. I'll explain exactly what you're going to need to use when we look at the level parser itself. But let's say we want to do something like, I don't know, let's say we have an int like sum, and we started at 0. And if the name is Jesse, for some reason we want to add 5 to sum. Once we're done, we want to write break. And break is basically saying, like, okay, we're done with the switch case, let's get out of the switch case. But let's say it wasn't Jesse, then we still have other cases to go through. So maybe it was Paul, and if it was Paul, let's add 3 to the sum, and then we want to break again. So break is useful when we don't want to return like the method, but we still want to do stuff afterwards, but we do want some output from the switch case. So super basic examples of a switch case here. If we were returning an int, we don't need the break if we're just returning. So let me switch this method signature a bit, make it an int. Let's say if we get Jesse, we just want to return 5. And if we get Paul, let's return 3. So, and the only reason this method's giving an error is because we don't have like a default value after the switch case. But that's in a nutshell like the most basic use cases of switch case. It's the same exact thing as if else. It's just built a little differently for visualization. You might be asking, why not just use if else? The reality is that you could. The only reason we use it is because it's easier to read. So I'm going to write the same exact syntax in an if else sense, and you'll see what I mean. Okay, so wrote out that if else if statement, and these behave the exact same. The only reason why I'm getting an arrow is or a yellow line is because the switch case is already returning. But this is just for the example. If I commented this out, it would work the exact same as the switch case did. So, the switch case just looks a little bit more readable. Our cases are pretty direct, like, okay, Jesse, return 5. Here it's like a little more like messy, but they really do the same thing. So when you see a switch case, don't feel intimidated. And so now we're going to look at the level parser. And this method is just garbage, by the way. I just did it for an example. But let's look at read dynamic object, for example, in the level parser. So I'm going to go back here, press Shift, and just type read dynamic object. Yes, Shift works with methods as well. So we're right here in the level parser, and we see a switch case. So this switch case is switching on split.get of 1. What the heck is that? Well, we see that split is an array list of strings. So an array list dot get of 1, so that's some string. We're switching on some string. Okay, that makes sense. So that's just the same exact thing as our name example from before, right? Like, we're switching on some name. Okay, it's basically doing the same thing. So if the name is daemon, then we're returning a new daemon object. Right, because a daemon is a dynamic game object through inheritance, so that makes sense that we could return it. Because if we click on daemon, we see that it extends enemy, enemy extends agent, agent extends dynamic game object. So it's this whole big tree of things, and we're slowly going backwards and backwards. So a daemon is a dynamic game object, so we could return it as one. So great. And we're doing that for tower as well. And don't worry about this default thing. Default is basically just the else of a switch case. So if we wrote here, I'll go back to our test utils. If we wrote default here, it's like, okay, if it wasn't Jesse or Paul, let's just return 1, and that would take care of everything. So that's just what default is. It's basically just the else part of an else if statement. So let's go back to the read dynamic object method. And yeah, daemon tower, and we see we're tasked with adding Goomba and Koopa. So it's really not too different than anything we see already. We're just trying to get you used to, like, okay, when we're adding more things to a big project, we have to change our parser, and this is how we're going to actually be able to see our new, Goombas and Koopas in our Mario game. So think about how you do that, and then it's basically the same exact thing for the read static object, but I want to mention one more thing about a switch case. All right, so I'm going to get rid of this if else if thing because that was just for the example. So one more thing about a switch case is that you could take care of multiple conditions at once pretty quickly. And I'll show an example of this here. So I'm going to add another case, but I'm going to say, and just for the heck of it, I'm just going to do it between Jesse and Paul. No reason. But all right, I'm going to add another case, okay? And I'm going to say, what if it's Bob? I don't know who Bob is, but if it's Bob, then I want to return 1. Okay, simple enough. We have Jesse, Bob, Paul. This is completely optional. You could get the picture done the same exact way by just adding, like, let's say we have 3 people, Bob, Alice, and I don't know. I'm just making up names here. So like, let's say we had like Bob and then like Alice. They're both returning one. Like they're like doing the same exact thing, right? But we're using two cases on them. We can make this a little easier to read by just adding a comma. So Bob, comma, Alice. Simple as that. And I'll get rid of this one here. This is doing the same exact thing. If it's Bob or Alice, we're returning one. So that's a way to do it. And I'm not gonna go too much farther on that. But if that helps you out at all for your read static object, then that's great. Don't have to use that, but just something to think about there. So I can't say too much about the parse level method modification here because, well, all that code is stuff that you guys wrote for task 0. But what I will do is I want to show the example of what the level CSV files look like and where that type actually is in terms of if it's a top-down level or a Mario level. So if we take a look here inside the project, this is an example of a Mario level. So we got so much static game object data in here, right? But we'll notice that the very first line and the very first entry is the level type, Mario level. If we take a look at some of these other levels here, we got top-down levels. It's always the very first entry, very first line, very first value. It will always be the level. So keep that in mind when you're creating your parse level modification. Yeah, because you have to make it dynamic to the level type. So if it's a top-down level, you should create a top-down level object. If it's a Mario level, it should be a Mario level object. Right now, you probably have them all being top-down levels, so take a look at your code, see how you could change it to check this first value, and depending on what this first value is, make the corresponding level. So good luck with that. But that's pretty much the hardest part about this part, about the level parser class. It's really just like understanding what you need to write, and knowing what the switch case is. So that should go relatively smoothly, at least this part of the task.
Wow, that was some good stuff. I'm glad that we got to learn all about that. Now, it's time to talk about find path and follow path. Now, there's some interesting points about these methods that we're going to explore. There's one really cool trick that, if you implement it correctly, it'll make find path a lot easier. But it's a bit hard to get a hang of, but we'll briefly talk about that in a bit. But, so, what is find path? So, find path is a static method, which means it does not specifically belong to any object. It belongs to the Pathfinding utils class. Okay, which means that we could call it from anywhere. Sounds good? Now, find path takes in two vector 2D objects. As parameters, returns a linked list node of vector 2Ds. Now, what does this mean? So, if we have two vector 2Ds that were taken in, that means that we have two positions in the world, and we're expected to find the path between the two. Now, hold your horses, everyone. This isn't as hard as you might expect, because we're not avoiding walls right now at this point. We're just returning any path, disregarding any obstacles that might be in the way. We're just returning a path. So, let's take a look at an example here. So, let's look up at this little graph here at the start. And here I have denoted some nodes in the world space. And I'm saying the start that we're getting passed in to find path is 0, 0. And our end is 2, 3. Okay. And our goal is to find a path between the two. Now, naively, without doing the whole avoiding walls or obstacles thing, what we could do is just, connect the dots basically. We could go from 0, 0 to 1, 0 to 2, 0, and then start going down, which is actually, up in coordinate direction, but whatever. We start going down, and we pretty much just make a path. So we go like right and then down in terms of here. So horizontally and then vertically is another good way to think about it. Now, we could, visualize how this might work. We keep incrementing this until we get to that or whatever, we slowly transform start into end one by one. But now the trick here is we have to maintain this in a linked list that should look like this at the end of the day. So this is the linked list that you have to return in this exact example. Okay, so I would really recommend that if you're struggling with this task a lot, this portion of the task, write a test case that exactly shows this example here. This is a really good test case. Given a start and end like this, make sure that you return a linked list that looks like this. Okay, it's useful stuff. So this linked list is a valid path because the first node in the list has a value that is of type vector2d, this right here. So this black box here is our linked list node. Okay, it's a linked list node of type vector2d. So its value is a vector2d, which is 0, 0 in this case, and it has a reference to the next value in the the next linked list node that has the value of the next position in our path. So 0, 0, 1, 1, 2, 0, 2, 1, 2, 2, 2, 3 to null, because this is the last one. So our linked list should always have our first node as the start and our last node as the end. Okay. And we know a node is the last in a linked list because it points to null. Okay, as its next node. So this is just the intuition, right? This is a visualization of how this find path stuff will work. One thing to keep in note is this is direction in our coordinate system in our world, right? So this right here, 1, 0, adding this vector here to any other vector would mean that it's going to the right by 1. So this is right, and then this is up, believe it or not, even though it's -1, it's up in our coordinate system. This is left, and this is down. Okay, so make sure you keep this in mind when implementing this, because an important feature here is that this path has to be a valid path. Now, what does that mean? Well, a valid path is a path that does not contain any decimal values in any vector2d in the list, and where every vector2d, adjacent vector2d, only differs by 1. So, if that was confusing, I'll give you an example of 2 invalid paths. So 1 would be a path where I have like 0.52, like this is my first node, and then it's already invalid. If any node has a vector2d with any decimal values, it's an invalid path. Another invalid path is one where here I'll do this right here. Okay, so let's say that these are parts of the same path. So these are 3 nodes in one path. Let's say the middle one here is 1, 1. That's the, here, I'll draw a different color just so it's clear. 1, 1 is the position. If any adjacent nodes in this list differ by more than 1 exact unit in the x or y, it's not a valid path. So if this was, say, 2, 2, this is not valid. Okay? And don't stress too much about, a valid or invalid path. If you follow the rules of how you should do these things, you should naturally return a valid path. So, the most important thing to keep in mind is that your start parameter that you're passed into find path might not be whole numbers, right? It might be some decimal value. So keep in mind what to do in that situation. You're going to want to basically discard the decimal portion of that double, which you could do by flooring it. Look into I think it's math.floor, but just keep those things in mind, okay, of returning a valid path. And now, so earlier I mentioned this tactic of a way to implement this method here, and I think it's time to finally talk about it. So the thing that everyone's been waiting for, recursion. Recursion is a fantastic way to implement a method like this. Now, it's not required. You don't have to do it. Okay, like if you're a big like, ugh, I don't like recursion, then you don't have to do it. But it will make your life easier learning recursion now for future tasks, future classes. You should get good at recursion early if you can. If you want some intuition here, I have pulled up here this previous task video from 2 semesters ago, actually. This is a recursion example from lecture slides of the append method of a linked list node. Um, I would take some time, like, think about it. Like, okay, it probably makes sense to you. Like, this is a pretty simple example, but the flow of recursion, you're calling that same function inside itself, and you're trying to get things slowly converging to some value. In this case, we're slowly trying to build a path with linked list nodes. So if you want to know more about that, it's optional. It's up to you. I really like there's some intuition here of how you would set this up from this task video. More specifics you could go into here. I'm not going to go too deep into it in this video because the requirements are a little different. You don't need to complete this task to pass technically. So if you want the points, if you want as many points as you can, I totally recommend doing recursion. I would, take a look at this and see if this makes sense to you. Try to think about it yourself. But that's fine path. Basically, you just want to return that linked list node. And when I say linked list node, I mean the reference to the first one, because this contains the data of the entire linked list, right? Like this first node points to the next one, points to the next one, and so on. So that's find path. Let's talk about follow path. So for follow path, honestly, compared to find path, it's not as bad. Here's the trick with follow path. So what you have to realize is that there are always 3 states that this function should be executing. It should be only executing one of these 3 states at a time. Okay, so this follow path method will be called each update. Okay, which basically means it's going to be called very frequently in the game. And since it's called so frequently, it's fine to be like constantly calling one of these 3 states. So your job basically is when this function is called, examine the state of the world and see which of the 3 states you should be in. Okay, so what I mean by that, in the idle state, if your instance variable is null, right? So this is the condition right here. If the agent's path instance variable is null, you should do something. Okay, how you should think about some of these like tasks and assignments is like, how could I break them down into smaller problems, right? So personally, what I look at this and what I think is, all right, I could see here, I have 1, 2, 3 explicitly labeled for me, right? There are 3 conditions in which stuff should be happening, which makes me sound like I should set up the frame of my like if else condition like right away. Okay, because then like once you have that structure set up, you could start working on the inner contents of each of those sections, right? So idle, I have my first if condition here, and then else if I check this, and else I do this. Okay, set that framework up first, and then start looking into the actual functionality here, because the actual functionality isn't too bad. It's a little bit of math that's basically given to you, so keep that in mind. But the one unfortunate thing is, yes, you can't see too much of this yet unless you do this bottom part where they'll actually follow the path. But just do keep in mind that this will be changed in a future task, which is totally fine. But it is quite useful for like debugging and all that to be able to see, these agents move along their path. And you could press F5 as well. That will just display the path in the game. So do that. It'll look like what I showed earlier in this video. But follow path, my recommendation here is to set up the framework of the 3 conditions and start working on that there. But that's pretty much everything for this task video. yeah, the bulk I'd say is find path. You know, if you want to experiment with recursion, I definitely think that you should. It will be worth it. Oh, by the way, yeah, it's vector2d.floor earlier, not math.floor. But yeah, so good luck on the task, everybody. Shouldn't be too horrible. You know, I recommend that you spend the most time on find path. That's what's going to probably take most of your time. But, you know, just try to get all the points you can. You know, really try hard on this one. So, yeah, that's about it. I will see you guys in the next one.